Well, good morning, good afternoon, good evening, everybody. My name is Tim Downs. I'm with Enterprise 5G, and we are here today with another one of our webinars on along the subjects of private networks, private 5G, and the business opportunity that's emerging in that world. Joining us today is Ed Pichon. Ed's with MFA. Which previously was called the Multi-Fire Alliance. Ed's going to talk today for the next 45 minutes about MFA's identifier management program. So Ed, I'll let you take it away. Tell us a little bit about yourself, about MFA, and then take it away.
Excellent. My name is Ed Pichon. I think my formal title for the MFA is I am the certification authority. I'm staff for the Alliance. I work for the Alliance, not any of the particular member companies. And my role in the organization is to be an unbiased, impartial process referee. I administer the certification program, and I also run the identifier management program for the Alliance, which is what I'm here to talk about today. If you have any questions, please submit them to the Q&A tool, and I'll try and get to them. I may not get to them immediately if I know I cover that question later on in the talk. If there are questions we don't get to, I'll follow up by email. And if you ever have any questions, please feel free to reach out to me at ca@mfa-tech.org. That'll get to me, and I'll be able to answer any questions you have. The things I'm going to talk about today, we're going to talk about a little about how LTE, 5G, and our work from the perspective of identifiers in those systems, to explain why we need to have managed identifiers, and then talk about what are those identifiers that we manage in the MFA, and then walk through the process of actually getting those identifiers from us. And then lastly, I'll try and answer some of the questions I've received in the past, hopefully address any questions you have here with our FAQ section. Now, today, I'm mostly going to be talking about 5G NR, but a lot of this also applies to LTE. I'm assuming everybody here knows something about these technologies, so I'm not really going to go into great technical detail on the innards of how they work. But there are some facts that we need to make sure everybody's up to speed on. And if you're not familiar with how identifiers work, it helps to get a little a refresher course, because it's not something that that often comes up in the course of people doing 5G in our work. So primarily we'll be talking today again about 5G. The 5G NR standard will be looking both at release 15, which is the first full release of the 5G system, looking primarily at standalone networks. We'll also be touching on release 16, which added a feature amongst the many other features that were added as part of the release 16 effort, the addition of something called a standalone non-public network, and talk about how that relates to doing private LTE or private 5G networks. And we'll also be talking about LTE in general as well, but we can mostly be focusing on 5G. And if you're not familiar with the MFA, as Tim mentioned, it used to be called the Multi-Fire Alliance. And that was the initial effort of the organization, was to adapt LTE to add support for operating an unlicensed spectrum. So added things like listen before talk and some additional capabilities as well to the basic LTE setup. In 5G, though, the 3GPP added a lot of the capabilities that were needed to support unlicensed private networks. And so the focus of the MFA has shifted in 5G to focusing on blueprints about what are the features and capabilities in the suite of things that 5G has that are really needed for private networks. And as a basic, hopefully you all are aware of how this works, how 3GPP mobile networks work. You have user equipment that talks over a radio access technology to base stations, and those base stations are coordinated and controlled by a core network that handles a lot of the network services, routing data to and from devices, etc. So hopefully this is not a surprise to any of you. But this is just at a high level to make sure we're all in the same place. Now, when you're talking about these networks, one of the most important things from the perspective of a user device, user equipment, is to try and figure out which network is the network they are a subscriber to, which base stations, which towers should the phone try and connect to. And the way that's handled in a 3GPP network, both LTE and 5G, is that they are identified by something called a public land mobile network identifier, a PLMN ID for short. This is a system that's been around for several decades. It's used as part of identifying a bunch of other different networks as well. And this identifier, it's a 6-digit code, sometimes it's 5. It consists of a 3-digit country code, and depending on the country, a 2 or a 3-digit mobile network code. And this system was defined and is managed by the ITU, the International Telecommunications Union, but they have delegated a lot of the day-to-day activities to various regional management bodies. So different country codes are essentially managed by different organizations. So for example, the US, which has 3, I think, different country codes, it's all managed by a company called iConnective, iFast, and they're the ones delegated to manage these PLMN IDs. And these IDs are broadcast by 3GPP networks on a continual basis. And phones have stored on them, typically on the SIM, the PLMN ID of their home network, in which case it's called a home network identifier. And that's what the phone uses to figure out which base stations it should try and talk to. It listens for these PLMN IDs being broadcast and connects to the one that matches their home network identifier. And there's a bunch of other variants of this, and it's a lot more complicated than that. There's a temporary PLMN IDs and home PLMN IDs and all this other stuff. But that's the basic idea, is these networks broadcast a PLMN ID that the phone looks for. And in 3GPP networks, in addition to identifying the network, that identifier, the PLMN ID, there are a bunch of other identifiers that are used to identify components of a 3GPP network that need to be globally unique. And the way that the 3GPP ensures that a network ID is unique is that they included the PLMN ID in that identifier. So if you look at some of these identifiers, looking at the first one, the GUAMI, the Globally Unique Access and Mobility Management Function identifier, this is the component of the 5G core network that handles mobility management. And it has this identifier, the globally unique AMF ID, and it includes, in part of that ID, it includes the PLMN ID. And that's how they ensure global uniqueness. It means if you're a network operator, you are responsible for assigning these, the globally unique AMF ID and managing it internally. If you mess something up and you accidentally have a collision, it only affects your network because other networks are using their own PLMN IDs. And this shows up in a couple of different numbers. The 4 big ones are this GUAMI that I mentioned, which is related to mobility management. There's the GUDI, the Globally Unique Temporary Identifier. And this is something that's assigned by the AMF to a device, a UE, on a temporary basis to identify it. And this also is used in mobility. And then there's the NCGI, the NR Cell Global Identifier, that uniquely identifies each cell. Each base station may have 1 or more towers, essentially antennas, and each of those towers can have multiple cells, and each one has its own cell global identifier. And this is primarily used as part of the self-optimizing network system and some of the mobility stuff. But one of the things that happens in 3GPP networks is the base stations can tell the UEs to go and measure the signals they're receiving from other cells, and they use the cell global identifier to identify which cell it should go listen to. There's also something called the tracking area indicator, going a little bit more detail on that. And this is used for mobility. And then lastly, there is the IMSI, the individual mobile subscriber identifier. And this is what's stored on the SIM card that identifies a UE or subscriber to the network. So these are the 5 big places where you see the PLMN ID used to ensure global uniqueness. And so for diving a little deeper into the tracking areas, because this becomes important later on, is that a 3GPP network is divided into tracking areas of multiple towers, multiple base stations in geographic areas. And phones, as they move around in the network, as the UE is physically moved around, whenever they see that the tracking area identifier that's broadcast by the towers in its area, if that changes, it notifies the network and says, hey, I've moved to a new tracking area. And the network, the core network, the AMF, actually manages this. And the idea is whenever they need to reach out and establish a connection to the UE in question, they know which tracking area it's in. So the AMF can tell all the towers in that tracking area, please try and page this device so we can then establish a connection. And this is one of the aspects of network topology design, is how big or how small do you make your tracking areas? If you have small tracking areas, your handsets, the UEs will be making lots of tracking area updates as they move around. So you have an overhead traffic on that end, but whenever you try and page the device, you're not as occupying as many towers trying to reach out and establish a connection to the UE. Conversely, if you have really big tracking areas, your amount of update traffic of then phones notifying that they've changed tracking areas goes down, but you consume more resources when you're trying to connect to that device. And this is something that's normally handled as part of normal network design on the part of the carriers and the major network operators. For smaller private networks, like things you can do with multi-fire or Uni5G, you'll probably want to have multiple tracking areas, one per each isolated island of coverage. So if you have multiple buildings on multiple campuses scattered around a large geographic area, one of the things you would do is you would set each area of coverage to have its own tracking area. So in small network deployments, you might end up with a fair number of tracking areas, depending on how you design your network layout. So that's tracking areas. Now, the PLMN ID system, as I mentioned, has been around for a while, and it works really well, but it was designed to support a small number of large public networks. That's what the system was designed to do, and it does that quite well. But it does have some issues when you try and support a large number of small private networks. The system's not designed to handle that because we have a fairly limited number space. It's 6 digits long. You only have, if it's a 2-digit mobile network code, you only have 100 networks per country code. And if you're having lots and lots of private networks, the system just won't work because there aren't enough numbers available. And in a lot of jurisdictions, they've imposed some pretty significant administrative burdens on getting your own PLMN ID. So like in the United States, you can't really get one unless you have a Spectrum license is required for them to assign you a PLMN ID, or at least that's what they try and enforce. So the system of the PLMN IDs just doesn't really work in the context of small private networks. And so we need to modify the system somehow to support lots of small networks with minimal disruption. And the solution that the MFA has pursued is to get our own PLMN ID. We actually went to the ITU and actually got them to issue a new country code, 902, for standards organizations. And we got the first network code assigned under that country code to the MFA. So we have our own PLMN ID, it's 90201, and we are sharing that to people deploying private networks. If you don't have your own PLMN ID, you can use this PLMN ID for your network. If you don't want to go through the process, or you can't go through the process of getting your own PLMN ID, you can just use ours. This does create two problems, though. One is that the identifiers that are supposed to be globally unique, if we're not careful, if multiple organizations are using the 90201 PLMN ID, they might accidentally assign the same identifier to, say, the GUAMI. And if that happens, you have what's called a network collision, which is bad. The other thing you can have, the other issue that comes up is how can a UE tell which network is the one it's supposed to connect to if you have multiple networks in an area broadcasting this 902.01 PLMN ID. It means we need some way to distinguish networks that use the same PLMN ID from each other so devices know what to connect to. And what we're really trying to prevent is identifier collisions. If two different companies, two different networks accidentally reuse the same identifier, which is more likely when they have their own, when everybody's using the same PLMN ID, you can get serious degradations in performance. In the case of Guami or Goody collisions, you can get denial of service, drop calls, interruption of service. NCGI collisions can be really subtle. They can disrupt the self-optimizing network systems, which it can result in increasing interference between your cells, as well as interruption of service. Tracking area update or tracking area indicator collisions likewise can cause interruption of service. And there's a really unpleasant circumstance of how some of the timers work, that you can actually get a case where the phone is denied service for 12 hours because of one of the error timers that's given there. So in general, all of these collisions are bad. It means your users can't get on the network or they lose connectivity. So we want to avoid these collisions if at all possible. And the solution to the collision problem is what we call our managed identifier program. And so the solution the Multi-Fire Alliance has deployed, the MFA has deployed, is that we manage components of those identifiers so that if you are using the MFA's shared PLMN ID, you don't have to worry about collisions. We manage it for you, so you don't have to worry about it or coordinate with everyone that's using this 902.01 PLMN ID. And the way we do this is we manage a component of these identifiers to ensure that the entire identifier, when including the PLMN ID, is in fact globally unique. And so if we look at the different identifiers in 5G NR, if you look at the Guami, it has the PLMN ID, it has the AMF identifier, which includes a region and set ID as well as a pointer ID. And so what we do is we manage the region and set ID, and that allows us to prevent these collisions. And you also have these extra bits left over for the pointer, where you can actually have multiple AMF instances for each of the AMF region and set IDs that we assign. The same set of the AMF region and plus set ID also shows up in the GUDI. In the NCGI, the cell global identifier, there's a GNode BID that we manage. And for the tracking area indicator, we manage the components that's called the tracking area code, or TAC. So what we do is we manage these components. And that means that if you're using our shared HNI and you're using one of these managed components, we only assign each identifier once. And that means you don't have to worry about having network collisions in your small network, your private network deployments. Now for the MC, we do something a little bit different. Rather than making you come to us for every MC you want to issue, what we've done is we've broken up a component of the MC, which standard is the PLMN ID plus of the subscriber identifier number. It's the MSIN. We've divided this 10-digit MSIN into a 6-digit MC block number and a 4-digit UIN. And we assign the MC block number, which then allows you as a network deployer or operator to issue up to 10,000 MCs per MC block number. And so this is how we make sure there aren't identifier collisions. We manage these identifiers for you. You come to us, you get them, and you can deploy your network. And you don't have to worry about having any of these collisions because we've managed that for you. You don't have to worry about it. Now, I've been talking primarily about 5G, primarily release 15 5G is where this comes in. LTE, if you're doing a conventional multi-fire network, the idea is basically the same. We manage certain identifiers, the components of those identifiers that need to be globally unique. And they are all pretty much analogous to the same identifiers in 5G. They just have slightly different names and bit lengths. In a couple of cases, like it's the MMEGI rather than the AMF and region and set ID, but it's the same basic idea. The functionality is the same. It's just the length, the name and the bit lengths have been changed in a couple of places. So LTE works entirely the same way. Now, this covers how we make sure that these globally unique identifiers don't have collisions. What I haven't talked about yet is how do you actually ensure that you can identify the network, distinguish between different networks. In an LTE, what we do is we have defined a new identifier called the private network ID that uniquely identifies a network that's using this shared PLMN ID. It's 27 bits. We manage it just like those other identifiers. And LTE includes this handy little mechanism called the closed subscriber group, which does exactly what we need in terms of treating networks independently, authentication, roaming, all that gets handled exactly how we need this thing to work. So we just use the CSG ID field to send the private network ID. And a device can have that on its SIM, the private network ID in the CSG ID field, how it's stored on the SIM, and it will just connect to networks that are broadcasting the PLMN ID, the shared PLMN ID, and the private network ID that we've assigned to them. And it's great. You don't actually have to make any modifications to LTE to make this work. However, there is one slight problem with this. Actually, there's two slight problems with this. One is that in LTE, not a lot of devices support this mechanism. There's little demand from the network operators, particularly inside the United States. There's no demand from the network operators, and it does have a potential impact on idle power consumption if you implement this mechanism. So a lot of the device makers have implemented the CSG mechanism in their software, but they've disabled it in their primary software builds, particularly on the UE side. The other issue is that 5G release 15 does not have a similar mechanism to the CSG ID and CSG mechanism. There's something called a closed access group added in release 16, but it doesn't quite do what we need, and there's a better option in release 16. The good news, though, is even if the devices don't support this in LTE or you're using 5G release 15, the actual impact on performance and to the users is fairly minor. Devices, if the device is in an area with multiple networks that are using this shared HNI, the shared PLMN ID, it will try and connect each one of those. But the connection will fail because at the authentication stage, the network will say, I don't recognize your MC, your user identifier. I don't recognize you. And it will reject the connection request. And the phone will then say, okay, well, you don't connect me, so I'll go to the next network that I see that's broadcasting this, the 902.01 PLMN ID. The end result is that the network acquisition time, the cell acquisition time for a device goes up, but it will also cause an increase in failed authentication traffic, but it doesn't cause a denial of service. Users will still be able to connect. So that's the good news on that. So that's LTE and release 15 of the 5G specs. But we want to talk about the later specs. I think they're like on release 19 in the process now. And release 16 added a feature that's very important if you're trying to deploy a small private network, and that is the creation of standalone non-public networks, SNPNs. Oops. And this is a feature that was added in release 16. And what they did is they defined a release 16 standalone non-public network identifier. And included all the functionality in the specifications for supporting use of a shared PLMN ID. And they defined a couple of different modes for doing this SNPN. And the one of interest to us is mode 2, which says that this network ID is globally unique when combined with the PLMN ID. And in the case of an SNPN, you can use the MFA's shared HNI and then use the private network ID that we've already defined. The bit link's a little different, so you pad a couple extra bits at the beginning, but you can use the MFA private network ID as your network identifier and then use the shared HNI. And that's all you have to do. Everything else is taken care of in release 16. You don't have to get any other managed identifiers. In fact, all you need is this private network ID and everything's taken care of. So release 16 makes this really nice and very simple. So I do want to make one additional sort of technical note. It's that the number spaces between LTE and 5G are separate number spaces. While the bit lengths are often the same, and the fields function the same, we treat them as separate number spaces. You can't use the MMEGI that we assign in LTE as your AMF region and set ID. You have to get those separately. The only case of that's not the case is with the MCs. Those are the same number space. They're unified for LTE, Identifier, and Unified G. So that's the technical explanation. Why do we need to manage identifiers? What are the identifiers that we're managing? And now we get to the process of how do you actually do it? How do you get identifiers from the Multifier Alliance, or the MFA? I'm sorry, it's not MFA. It's no longer the Multifier Alliance. And the process is really simple. You go to our website and you order the identifiers from us. It's very straightforward. We do have an identifier usage agreement where basically it's a click-through legal agreement. Don't request identifiers you don't need, and help us troubleshoot any collision problems that might happen in the field should they come up. You tell us how many identifiers you need, you pay a fee, I assign the identifiers to you, and I send you an email saying, here are the identifiers that have been assigned to you. It's really quite straightforward. Some of the questions that come up in relation to this, of course, are who can get identifiers. It's open to the public. It is not restricted to members of the Alliance, of the members of the MFA. Members do get several sets of identifiers as part of being a member, depending how many, it depends on their membership level. And we've even defined a new membership tier, probably called a private network subscriber, where they can get access to our mailing list and get promoted as a member, and they get a free set of identifiers at that level of membership. But you don't even have to do that if you don't want. If you don't want to be a member, you can just order the identifiers. It's easy peasy. We don't require membership. We do charge a fee, of course. We list the fees here on the slide. You can see we also have an identifier package, both at LTE and 5G, which is sort of the complete set of identifiers you need at a reduced price. And if you need additional identifiers, you can get them a la carte. Though one of the most common questions we get is, how many identifiers do I need? And we have this listed here. You need one private network ID per independent network. You'll need one AMF region set ID, or if you're doing LTE, one MMEGI. Each of the instances that are identified by that, the AMF or the MME, they can handle a lot of devices. And for each of those identifiers, you can actually do a bunch of instances of your MMEs or your AMFs. So with one of these identifiers, you probably have more than enough capability. If you ever end up needing more than one AMF region set ID or MMEGI, that means you have a really large network, and it might make more sense for you to go ahead and get your own PLMN ID at that point. We also recommend one G-Node B or E-Node B ID per base station. In theory, you can use the cell ID to distinguish between different base stations if you want to use that same G-Node B or E-Node B ID for multiple base stations, but it does cause a little additional administrative headache. You have to keep track of which cell IDs you put where. So we just recommend you do one ID per base station just to keep it easier. And for tax, as I mentioned before, you'll probably want to have one tracking area code per coverage area for each isolated island. And you'll also need one MC block number for every 10,000 SIMs. If you find yourself, you're going to have more than 10,000 devices, you can get an additional MC block number. And if you're deploying a standalone non-public network, all you need is one private network ID. And that's pretty much it. That's how many identifiers you need, how much they cost. And so now I will pause and start going through some of the frequently asked questions. see if have we had any questions submitted yet? No, we haven't. So hopefully I'll cover all the questions you may have. So how long does it take to go through this process of getting identifiers? Doesn't generally take very long, typically 1 to 2 days. It's frankly just how quickly I can plow through my email every morning. Do you need to obtain identifiers? The answer is if you're deploying a network, particularly if you're deploying MNFA or Unified G network and you don't have your own PLMN ID, yes, you're going to need identifiers from us. If you're a device maker, no, you don't need identifiers. We have reserved the top 10 of each number space for development and testing purposes. And these identifiers are things that are assigned at time of deployment, not time of manufacture. So if you're a device maker, you probably don't need identifiers from us. When should you obtain the identifiers? The best time to do that is anytime before you turn on your network. You can't turn it on unless you have these identifiers because it won't work. We recommend, though, you do it fairly early in your process of deploying a network, primarily because it can take some time to issue SIMs to get those cut. And you'll need that MC block number. So the sooner you can get that, the sooner you can start issuing SIMs. Also, if you don't need identifiers anymore, you can, of course, cancel them, and we will return them to the pool of potential identifiers that we can assign in the future. Though to prevent any accidental collisions, we put them at the bottom of the pile. So any canceled identifiers will get eventually assigned, but at least initially they won't be reassigned for a while. Let's see, more questions, frequently asked questions. Does my network need to be a multi-fire or unified G network? No, it does not. You can use these identifiers for non-multi-fire or unified G networks. We're open to anybody using them. If you're doing a private network and you don't have a PLMN ID, this is an easy way to solve some of the problems and some of the risks associated with using a shared PLMN ID. There is, for example, the 999 code, which is open and unmanaged. You could use that, I suppose, but this actually solves some of the headaches that can come up if you're using that unmanaged PLMN ID space, the 999 country code. I often get asked, are the identifiers confidential? Strictly speaking, from a technical perspective, no, they're not, because they're broadcast by your network. But from the perspective of managing the management of these identifiers, we treat these identifiers as confidential. The only time I share who has what identifier is if I get the permission of whoever that identifier has been assigned to. I do share aggregate summary information with the organization, the MFA. We've assigned so many eNode BIDs or so many GNode BIDs, but I do not identify who has been assigned which identifiers without their permission. So you don't have to worry about the fact that you've got an identifier will reveal certain development plans or anything like that. We treat it confidentially. I also get asked, if you're deploying a standalone non-public network, do I need to get an MC block number? And the answer is no. If you're doing this release 16 SNPN, you do not need to get an MC block number. Strictly speaking, by the specs, you're actually supposed to use something called a subscription permanent identifier, a SUPI, which is derived from your network access identifier, which comes out of an IETF, RFC, and it's that whole username at realm definition. And that's how you're supposed to identify users when you're doing SNPN. And in fact, by the 3GPP specs, you're not supposed to use MCs when you're in SNPN mode. We'll see if people start trying to use MCs and SNPNs, but we'll see. But strictly speaking, by the specs, you're not supposed to use an MC. So if you're doing an SNPN, all you need, again, is that private network ID, and that's all you need to do, and everything else is taken care of. Oops, let's see. Next one. Do I need identifiers if I'm deploying a neutral host network? Strictly speaking, technically, no. If you're deploying something like a MOCN or a MORAN, like a DAS type system, you do not need identifiers from us. So you can use identifiers provided by the participating networks, technically. Practically and politically, yes, you should probably get identifiers from the MFA if you're deploying a MOCN or even a MORAN system. And there's two reasons. One, if you get the identifiers from us, you can deploy a private slice or private hybrid network in your neutral host network. So you can have a private sector, a private slice if you get your own identifiers. In addition, some of the participating networks may actually prefer that you use your own identifiers rather than using identifiers from the participating network. So as a practical matter, for most neutral host deployments, you're going to want to get your own identifiers. There is also this thing called a multi-fire neutral host network. And if you're paying attention, earlier slide, you might have seen like the price listed for these. To explain what that is, the MFA defined a mode of the baseline multi-fire LTE specs that had included a neutral host access mode. It's defined in our 202 spec. And this uses a 40-bit neutral host identifier to identify that neutral host network. And if you're deploying a multi-fire NHN, that specific flavor of a neutral host network, you need to get this neutral host identifier. However, this does require changes to how the UE and the eNode B function to make it work. It's not like MOCN where you can just use a standard UE and not have to make any changes. To do a multi-fire neutral host network, you actually have to bake it into the software on the UE and the eNode B, because we've made a bunch of changes primarily at the RRC level to make this work. And as far as I'm aware, no one has deployed a network, a neutral host network that is this specific multi-fire flavor neutral host. So you probably don't need one of these identifiers, even if you're deploying an NHN, because you're probably going to be doing a MOCN or a MORAN system rather than the multi-fire specific flavor. If you are using the multi-fire specific flavor, I'd be very keen to talk to you and get the details on that. And in that case, you also need to get this multi-fire neutral host network ID from us. And it's one of our purchase options for getting identifiers. Let's see, lastly, if the CSG mechanism isn't supported in LTE or in release 15 5G or in release 16, if you don't support standalone non-public networks, why should I bother getting an MNFA private network ID? And there's a couple of reasons. One is because CSG mechanism has been implemented, that support may be re-enabled via software updates in the future on the UE side. So already having that private network ID already figured out and installed and put on your SIMs means that if that CSG support is added, you can take advantage of that fairly quickly. It is also used, as I said, in the release 16 and later standalone non-public networks, and it can aid in diagnostics and troubleshooting if you're broadcasting that CSG ID in your network, on your network side by the base stations, the eNode Bs and gNode Bs. So it's useful there. So we recommend you get one anyway. And if you try and order them right now, there is an update pending to the website, but right now the web portal only allows you to buy the LTE identifiers. If you order identifiers and you want the 5G identifiers rather than the LTE ones, just let me know. Send me an email when you order, and I'll take care of it and make sure we assign the right identifiers to you. So those are the most common questions I get as part of this. And with that, I am at the end of my talk. I don't see any questions on the Q&A panel. Tim, were any submitted via the text that I didn't see?
No, I don't believe so. So what we'll do is we'll just make available this video on our website and also on the MFA site, and we'll make available the registrants to MFA, and I'm sure we'll be able to communicate with those people any other questions they may have. Sound good?
That works for me.
Well,
and if you have any of those questions, again, also feel free to email me, ca@mfa-tech.org, and I'll do my best to answer them. My job is partly my job is to make it as easy as possible for people to deploy MFA networks, multi-fire networks, unified 5G networks, and make sure this the MFA's PLMN ID is used. So if you have any questions, suggestions, concerns, send me an email. I'll do my best to address them as quickly as possible.
Terrific. Thanks, Ed. Did a great job. Appreciate all the information. And we'll see you on the next webinar. Thank you for everyone for attending.
Thank you much.
Thanks, Ed.